From here, we will consider the double angle for cos 2 alpha. And in the same manner, cos 2 alpha can be expressed as cos alpha plus alpha. And then from here, we juggle it with that compound angle formula. Let's just quickly write it here in red, is equal to cos alpha by sine cos beta minus sine alpha by sine beta, and you would have something like that. Sorry about that. And from here, we now have, in place of beta, we have alpha. So it will look something like this. Oh, let's indicate this as a note. It will look something like this: cos alpha by cos alpha minus sine alpha by sine alpha. And so from here, it will be looking something like this: cos squared alpha minus sine squared alpha. And now this one is an interesting one, because then we can write it in the following manner: alpha is equal to cos squared alpha minus sine squared alpha. And we have that. It actually can be written in three different ways, depending on what situation that you are in, and it will be required for you to use your discretion to see which one is needed at the moment, at that particular moment. And if you remember, grade 11, the Pythagorean identity which we used most there was written in the following manner: cos squared alpha plus sine squared alpha is equal to 1. Now, not to be mistaken with this has a minus sign here and this has a plus sign here, so we can't really say it's 1, but there's something that we can do about this. We can now then say, in this case, cos squared alpha is equal to 1 minus sine squared alpha. So if you're looking at this, we actually transpose this sine alpha into the other side. And as well, if we take this equation here that I indicated by 1 and make sine alpha squared the subject of the formula, we will actually have 1 minus cos alpha squared. Now these two are going to be very helpful into us changing this. For instance, if only we are given a double angle of cosine, but then you are required to come with the solution that has cosine only or sine only, then you will use either one of these. Let's quickly see how we can actually substitute them into that formula. So we take back that formula to here. We will say cos 2 alpha is equal to, so now in place of cos squared alpha, we would have that 1 minus sine squared alpha, and then we would put this in brackets and say it's minus sine squared alpha. So in this case, we would then be having something that is in this manner, because now if you observe these two are actually like terms. So you would have the 1 there as it is, but then it would be minus 2 sine squared alpha. and then it stands. That is the first one. For instance, if you are given a double angle that is cos, and then you are required to come with a solution that only has sine, the sine function in it. The third and last one is this. Let's have cos alpha is equal to cos squared alpha, because we are now substituting sine squared alpha minus, then we will have something that is this in place of sine squared alpha. So from here we have this. The cos alpha squared is also 8th-like term, but then the first thing that we need to do is that we distribute this negative sign respectively to these two terms that are here. So this one will remain negative, but this one becomes now positive, and also this one is now positive. So the results will be looking in this manner: 2 cos squared alpha minus 1. So then we now have these three. Okay, sorry about that. We now have this one as the first cosine double angle, as well as this one, as well as this one. And so we write them in the following manner. We say cos 2 alpha is equal to cos squared alpha minus sine squared alpha, and the second one is 1 minus sine squared alpha, and the last one, is 2, supposed to be 2 sine squared alpha, and then the last one would be the 2 cos squared alpha minus 1. And all three are applicable depending on the problem, the situation, the time, and the manner in which the question is being required or examined. So I hope this was helpful, and even further, I will try to look for examples that have these problems at a maybe level 3 or level 2 questions, where there's a lot of calculations involved and there's a lot of understanding that you need to bring as well. But I hope you enjoyed these proofs and they will become useful to you.